what we want to talk about now is making sure our database remains consistent and we follow the integrity rules, and our data is has integrity, data integrity. Remember, one of the problems that we said exists with the file-based system is that there is no way to enforce the data integrity. There is no way to make sure the data is accurate. And so one of the advantages of the database management system is that it makes sure your data is accurate. And how does it do that? Well, what it does, it puts those constraints, it puts rules that forces the database management system to check the data integrity. How does it do that? Well, by adding those constraints. So when we saw that we can go to a column and say, we want to make sure that this column is unique, or we want to make sure that this column is not null. So these were rules that we've put in place so that our data that we are inserting into our database remains accurate and has integrity. So we call these rules constraints. So we're constraining the data that can be inserted into our database. Now, there are different types of constraints that can exist, and there are different types of integrity rules. So one type of integrity rule is called the domain integrity. It refers to the values that you want to allow for an attribute. So if we have a column in our database table, how can we make sure that the data that's put into that column is accurate? So that's called domain integrity. And so what we do to achieve this domain integrity was we choose an appropriate data type. So if you want a column that has a date, you don't select string, you select date. So if someone tries to put in a month that doesn't exist or has a typo in it, the database will catch that. So by defining the data type, we are maintaining domain integrity. Now there's another type of restriction. What if, I do put the date as the data type, but I want to restrict all my employees to be born after a certain date. So I want them to be born after January 1st, 1950, and I want them to be born before 2000, for example. How can I do that? Well, here, this is something I can't really do by defining the data type. So we don't call that domain, well, we call it domain integrity, but we want to put an additional constraint. So domain integrity here, we're defining the data type that we are going to allow, but we want an additional constraint. We want one more rule that says we want to limit this date to be between these two dates. So here we want to add another constraint, which is called an integrity constraint. And we will learn how to do that in a future chapter. There's another type of integrity, which is called entity integrity. Entity integrity refers to the integrity of the entity itself. How can an entity have integrity? Well, what we do is we require that every table have a primary key. So if you created your table without defining any primary keys, any attributes being primary keys, you have violated the entity integrity, because that means you can add duplicate data into your table. Okay, so if I try going to my database and say create table, let's call it bad, and let's just add some columns to it. So let's say name, which is a var char 10, and I don't know, age, for example, which is an int. Okay, so let's call it bad name. So here I've created a table that has 2 columns in it, and now when I try to insert into bad values, let's insert 20, and then what we're going to do is we're going to insert that value again. So let's create the table. Okay, and now we insert the first row, and then we insert the second row, and now let's look at our table. we see that our table has 2 rows that are duplicates. Now, there's no way to uniquely identify a row. Do I want the first one? Do I want the second one? There is no attribute that's a primary key. So this table is a bad table. It does not satisfy the entity integrity. We did not make sure that every row in our table is unique somehow. Okay, so here we have broken the entity integrity. So one of the integrity rules that we want to make sure we have when we are creating our database is entity integrity. You need to make sure that every table has a primary key, and of course the primary key cannot be null. Okay. Another type of integrity is called referential integrity. Referential integrity, it talks about the foreign key. And what we want to make sure is that if we have a foreign key in a table, that foreign key actually corresponds to a primary key in another table. That's the definition of a foreign key. A foreign key is the primary key in another table. Okay, so it's a key, but it's foreign to us. So it's foreign because it belongs to another table as a primary key. Now, if I look at this table here, I have a table that has a company ID and a company name. So I have a table that stores company information. So I have 2 companies, company 1 and company 2. Now, in another table, a child table, what I am storing is a product, you know, a product ID, a product name, and I want to see which company it belongs to. And so product 1 belongs to company 1. So if I go back and look at company 1, I see that company 1 is Apple. I have another product 2 that belongs to company 15. If I try to go back and look in my parent table and see what company ID 15 belongs to, I find that it's not there. And so what we say is that this row is an orphaned row. It's an orphaned record. It doesn't have a parent. So there's this foreign key does not correspond to a primary key in the parent table. Because it doesn't have a parent, we say it's an orphan. So it's an orphaned record. An orphaned record is one that has a foreign key that doesn't correspond to any primary key in the parent table. So we don't want to break this referential integrity. So when we're doing our foreign keys, we need to make sure that we don't introduce this referential integrity. We don't break this referential integrity. So 3 types of integrities that we're talking about right now is domain integrity. And we're going to achieve that by making sure that we specify the appropriate data type. We don't make everything just varchar and make everything just a string. No, we specify if it's a numeric, if it's a whole number, if it's a varchar, if it's a date, we specify. So the first thing is when we're choosing our attributes, we need to choose the appropriate data type. Okay. The second thing is we need to make sure that we choose a primary key for every table so that we achieve entity integrity. The next thing we're going to do is we're going to learn how to create our foreign keys so that we achieve this referential integrity. And so when we're creating our foreign keys, we need to make sure that we choose an option so that if the parent gets deleted somehow, the foreign key gets updated. Okay, so if I try going to looking at the tables that we had before, we have department. So let's look at the department table. How many departments we have again? And we have up to 9. So we have 9 departments. And let's just look at the employee table really quickly. And so these are the columns for the employee table. So what I want to do is I'm going to try inserting an employee that does not belong to a valid department. So that's what I'm going to do. So I'm going to say insert into employee values, and let's just say test. Oh, we need an ID. So 220. Employee 220, and let's just say test is first name, test 2 is their last name. Let's give them a salary of And let's give him a department of 20. And we know that a department of 20 doesn't exist. Let's give him a valid manager, 100. And let's give him a hire date of 20 December 20. Okay. Here, all the values that we are inserting are valid values. The only one that's not valid is the department, because there is no department number 20. Let's see what happens when we try to insert this. And so here it actually told us. So here the database caught that problem and it told us integrity constraint. You are trying to break an integrity constraint. And it's telling us that the problem is that the parent key is not found. Here I see the FK, so I see that something about constraint, that's a foreign key between the employee and department. So when they wrote the constraint name for this employee table, they made a good job choosing a name. So if I go to my employee table, the create command for the employee table, we'll see that constraint name there. So let's go to it and see it. So here we see that we are talking about this constraint name, which is identifying that this foreign key of the department ID is a foreign key that references the department ID in the department table. So here it's telling us that we are breaking this constraint. And so it's telling us that the parent key is not found. You tried inserting a foreign key, but there is no parent key. So the database does not let us do that, which is good, okay, because we've added the constraint right when we were creating our table, okay? So here we can't insert bad data. That's good. Now the problem that we are going to try to solve now is what happens if we try deleting a parent that is referenced. Now, if I try deleting a department, I'm doing some restructuring and I'm going to delete a department. What's going to happen to all the employees in that department? And so at the time of creating the database, you need to decide what you want to do if you are going to be deleting a primary key. And the options are, you can cascade update. So if I go and I change the primary key, so let's say a department was number 9 and I decided to make that department number 10. What do I want to do? Do I want to cascade the update? Do I want to make sure that all my foreign keys get updated automatically by the database for me? That's the cascade update. Do I want to cascade delete? If I delete the primary key, I delete a department. Do I want to delete all the employees that are part of this department? Probably not. You know, probably you don't want to do that for employees, but maybe in another case you might want to do that. Another option is set to null. If I delete a primary key, I want to just say set the foreign key to null and I'll deal with it later. I'll later go through my data and see what is wrong with this, with the foreign keys that are null, and I'll change them to something. So these are the 3 options that we can choose when we are creating our foreign keys. Okay, so so we saw an example of this. I'm going to skip that slide. Now, here we have some tables that were referenced in the slides before. So what I'm going to do is I'm just going to show you these tables. We're going to create them ourselves. So these were referenced in earlier slides. So we had a table called persons, and it was storing someone's person ID, like a unique ID like social security number or banner ID, their last name, first name, address, city, country, and balance that they have. So this was the persons table. And then I had another table called projects, and it contained a list of projects, the owner of each project, and the project title. And here the owner ID, this owner ID is a foreign key. It references the person ID in the persons table. So it's referencing this. Okay, so now I have a relationship between these 2 tables. They are related. And sorry, what I'm going to do is I'm going to insert some data into this database. So let's create this table. And let's create the projects table. And I'm just going to insert a person into my first table. So I'm going to insert a person. I'm going to give them an ID of 101. Okay, so now I have some data inserted. Now let's go and insert a project. And I want to insert that 101 is the owner. So I'm going to say 101 is the owner and the project is my project. So this should be allowed because 101 is a valid person. Okay, we have a person with ID 101. So let's insert this project in there. Okay, and it told me that one row was inserted. And now what I'm going to do is I'm going to try deleting this person. Let's see what's going to happen when I delete it. Let's just delete everything, okay? Because we only have one row. So I'm just going to delete everything. And it doesn't let me. It says project, there's a violation, a constraint that I'm breaking. It's a foreign key violation because the name of the constraint was there. It says child record found. You are trying to delete a parent and this parent has some children. And what it's saying is that you can't do that. You can't delete me because there are other tables that are referring to person 101. Okay, so the nice thing is the database is not letting me do the deletion. It's warning me. But how about if I did want, to be able to delete it? What should I be doing? Well, what I can do is when I'm creating my projects table, because I have a foreign key, I can say when I'm creating this foreign key constraint, I can say what I want to happen when the foreign key, the primary key that this foreign key is pointing to, what do I want to do if this gets deleted? So one option is on delete, do what? So here, what I want to do is on delete, I want to set to null. So we said there are three options. We want to cascade or we want to set to null. So what we're going to do right now is we're going to test the set to null. So I'm going to go back, and before I can do anything, I need to drop my table so I can recreate them. So here I'm going to say drop table. And remember, we always want to drop the dependent entities first, the ones that that depend on others. So projects is the weak entity. So I'm going to delete that one first, and then I'm going to drop the second table, which is persons, and that is the strong entity. So when we're creating, we create strong first. When we're deleting, we drop the weak first. So let's drop the tables. Okay, so I dropped them. And now what I'm going to do is I'm going to recreate them. But this time I'm going to go to projects and I'm going to say here next to the constraint on delete null. So if anyone tries to delete this primary key, set my foreign key to null. So let's recreate the two tables. Created the tables. Let's insert my person. Let's insert my project. And now what I want to do is I want to delete everyone in person. So I'm just trying to delete 101. And we're going to find a small issue. It doesn't let me. And now it's giving me a different error. The error message that it's giving me now is that it cannot update system projects owner ID to null. So it tried, here we told it when on delete set to null. So what it tried doing is it tried going to the owner ID. See, the error message says owner ID. It tried going to the owner ID and setting it to null because I told it set it to null. Set this foreign key owner ID to null. And when it tried setting it to null, it couldn't because I had a restriction here that said not null. So if I want to be able to use the on delete set null, I need to make sure that that column, that attribute can be null. So here I need to remove this little part over here. So I'm going to just delete this commented out. Okay, let's drop the tables again. And let's try and see if I remove that restriction, if on delete set null will work. Let's go back and create the two tables. So just gonna click here anywhere and create the first table, create the second table, do my first insert, do my second insert. Okay, and now I'm going to delete all my persons. And it let me do it. Now, what does the projects table have right now? Let's see. Let's say select star from projects. And if I look at my projects table, I will see that it has one row in it and the owner ID has been set to null. So this project that I had inserted initially with 101, when the 101 went away, poof, disappeared, it just changed the foreign key for me to be null. And so you can later go through your table and do, select where owner ID is null. And then, you can find all the ones that are null and try to figure out how you're going to fix those. Okay. So that is one option you can do, is when you are creating your table, say that when anything happens to the primary key that my foreign key is looking at, just, if it's getting deleted, just set it to null. So that's the first option that we can have. Another option is saying, when I try to delete, I want you to cascade this deletion. What does that mean? That means if I delete a primary key, I want to delete all its children. If I delete a person, I'm going to delete all the projects the person was working on. If I delete a department, I'm going to delete all the employees that work in this department. Now, again, this is a little dangerous, but maybe this is what you want to do. So let's try that on delete cascade. In this case, I can keep the not null. That's okay, because I'm not going to set it to null. Let's delete our tables. Let's drop our tables and recreate them. So I'm going to drop our tables and let's go back and recreate them. So this creates persons table. This creates the projects table with the cascade option on delete. I'm going to insert my person. I'm going to insert my project. And let's just make sure a project has something. So let's look at projects to see that it does have a project in there. And there is a project. Now I'm going to delete all the people. I deleted this person. Now let's look at the projects and see what happened to this table. And we find it has nothing, because when the person got deleted, all the children, all the entries in project that were referring to that primary key also got deleted. So that is what the on delete cascade option does for us.